day, everyone. Are you tired and sick and dealing with integral calculus problems, especially integration by parts? Let me and my teammates help you to understand integration by parts well with this video. Let's have our first example. Let's try integrating integral of x e raised to x dx. We could do this easily if it were just integral of e raised to x or x dx, because we can do that with the basic integration we have learned before. But in this case, we can't. We have the x multiplied to e raised to x dx. So what are we going to do? First, check if you can try algebra. Next, you can try substitution. If you choose your u, du won't be what you need to cover the rest of the integrand. These two tricks aren't applicable, so it's time to learn something new. Let's have the integration by parts with a formula. Integral of u dv is equals to u multiplied to v minus the integral of v multiplied to du. First, we need to pick our u and dv. In choosing u and dv, we can apply the Eilate trick. That stands for inverse, L for logarithmic, A for algebra, T for trigonometric, and E for exponentials. In using Eilate sequence, whichever type of function comes first, make that your u. In this case, the derivative of e raised to x is simply e raised to x. The derivative of x is 1. That's simpler compared to e raised to x rather. So our u here is x. And of course, our dv is e raised to x. Next, we have to find our du and v. Du is just simply the derivative or u, which is 1. Or simply dx. Next is we have to find our v. Our v is just the integral of our dv. So the integral of e raised to x is just e raised to x. Now we have to plug it into our formula uv minus the integral of v du. Our u here is x. Our v is e raised to x. Subtracted to the integral of v, which is e raised to x, and our du, which is dx. Now we have to simplify this one. We just simply copy this one because this is its simplest form. X e raised to x minus the integral of e raised to x dx is just e raised to x. And don't forget to add a plus c in your final answer.
For our second example, what is the integral of x squared sine 2x dx? So our first step is to identify our u and dv. As a rule of thumb, whichever factor that comes first in our integrand and gets simpler when you get the derivative of it, make that your u. So here, we have x squared sine 2x. So as mentioned earlier, we can use the trick called Eilate. So we have an algebraic expression here and trigonometric functions rather. So what comes first in Eilate? It is the algebraic function, and that will be our u. So our u is equals to x squared. And our dv, so here is our dv, sine 2x dx. So we can find our du and v by first getting differentiating our u and integrating our dv. So our du will be 2x and our dv will be 1/2 integral of sine 2x dx. So our v will be negative 1/2 cosine 2x. So after finding our u, v, du, and dv, we can now plug it in our integration by parts formula. So our u is x squared times our v, which is negative 1/2 cosine 2x, minus the integral of negative 1/2 cosine 2x times our du, which is 2x. So now, we can now simplify our functions. So, will be negative 1/2 x squared cosine 2x minus. So we have here two negative signs, so it will be positive 1/2 the integral of cosine 2x times 2x dx. So here we can cancel common terms to writing it, we will have integral of x cosine 2x dx. So here we have an integrand which we don't know how to solve. So it looks like we will gonna have an integration by parts again. So we will find our u equals to x, since we have an algebraic function and trigonometric function, and our du will be 1 dx. Our v is cosine 2x dx. So integrating it, our v will be 1/2 integral of cosine 2x dx. So it will be 1/2 sine 2. So we can now plug it in its integration by parts formula. So we're gonna have our u, which is x, times our v, which is 1/2 sine 2x, minus the integral of 1/2 sine 2x over du, which is dx. Simplifying it, we will have 1/2 x sine 2x minus 1/2 integral of sine 2x dx. So we will gonna integrate it. So we will have 1/2 times 1/2 negative 1/2 cosine 2x. Simplifying it, we will have 1/2 x sine 2x plus 1/4 cosine 2x. And then, we can now find its final answer, but don't forget what we have solved here. So, this will be equal to negative 1/2 x squared cosine 2x plus 1/2 x sine 2x plus 1/4 cosine 2x, and don't forget plus c. So this will be our final answer.
So you already know the concept of solving integration by parts function with its formula uv minus the integral of v du. Right now, I will discuss to you on how to solve it in a quick method with the method we used to call tabular method or DI method. The idea of this method is first we must break apart the integrand into two parts. Let's take the d or the derivative and the I or the integration of the function. So the u is for the derivative and the I and the dv is for the integration. And with the example we used earlier, we know that the u is x squared, so let's put it in the d. And we know that the dv is sine 2x, so let's put it in the I. For now, forget the dx. So let's take its derivative all the way down until it goes to 0. So the derivative of x squared is 2x, and x is 2 and 0. And let's stop to 0 because we cannot differentiate it any longer. And the integration of sine 2x, let's take x equals to negative, take out the 2, make it 1/2 cosine 2x, and integrate again, still 1/4 sine 2x, and integrate again, becomes positive due to same sign, 1/8 cosine 2x. And in the signs, always keep note that it goes in positive first, then to negative, and alternating all the way down. Okay. And then we multiply it diagonally from the first column of the D to the second column of I. So let's put an arrow. Then multiply. We can come up to the answer of x squared times negative 1/2 cosine 2x minus 2x times negative 1/4 sine 2x plus 2 times 1/8 cosine 2x. And then simplify. Now, common terms. Comes 2 and then comes 4. Then we can come up to a final answer equal to negative 1/2 x squared cosine 2x minus 1/2 I plus due to same sign, so sine and the x. Look at the x. Sine 2x and 1/4 cosine 2x. And this is the final answer. Easy breezy, right?
Thank you for watching our video. Hope that you have learned the simple technique in integration by parts. If you like this video, please feel free to like, comment, and share our video. Thank you so much.